Sometimes I will structure the teams by content strength, and when I do that, I try to spread the talent. So I'll try to put a strong student, or at least a strong leader, in every single team, so I can have strong performance throughout the board. Another way to do it, which gives some students some choice, and the only rule there was I can veto, because I can see if chemistry just ain't going to work. Another way is just to give complete choice, which we did for this one because it was the last time of the year, and they said, you never let us pick our teams. I'm like, fine, pick your teams. But we got veto power there. And the talent still spread. That was very interesting. The students still created really strong teams because they didn't want to pick people with poor work ethic.
But how would we know if it was too big? Not based on the color, but based on its size.
Find a star that's too big and find out what its radius is. And say, this star is too big.
But how would you know if it was too big?
Because it's too hot.
How would you know if it was too hot?
Because if it's too hot for liquid water to be present on a planet, it's too hot. That's what we're going by. We know we need to survive, and we need water. And if a planet's too cold to have liquid water, if a planet it's too cold to have liquid water, too hot to have liquid water, we can't survive on that planet.
We can't, but maybe another form of life could.
But she's talking about but we don't know. Every form of life on Earth needs water. So we're going to assume that every form of life in the universe needs water.
Okay, but that's just assuming.
But that's what we look for when we're looking for a habitable planet. We're looking for a planet that has water or has the right temperatures for water.
But she said that it didn't have to be just our life. It could be any type of life.
But still, we're assuming that every life needs water because we have no other information to make a different assumption. So we're going to assume that no matter what, all life needs water.
The reason why the team concept is really big for us is they immediately have a support group. They immediately have some people that they're going to talk to get things done and say, well, why did you do this? I don't understand that part. And they'll automatically help each other with either assignments or parts of the rubric or things like that. Peer collaboration is huge for us because even though there's 2 of us and we have smaller classes than a lot of other public schools, they have so many questions that it takes a while to get around to all of them, and the questions are usually so in-depth that you spend a lot more time at each area answering those questions.
I think it's G.
I'm about to see.
I think it's G.
What is it supposed to be?
Because it's the 5 is positive.
Mm-hmm.
The 5 is positive. You square root your 4, which gives you 16. And then the equation is asking 5 and 4. So your 4 is going to be a K. Your K is going to be 4 and your H is going to be 5. You see it? This is your K and this is your H.
Mm-hmm.
And then you have to square root your 4 because that's the radius.
Mm-hmm.
So he said, you know how he said you can go ahead and
Square root it just when
square
it's. Oh yeah.
So 16 plus your H plus your K. We would just put our K in the front.
And then,
Oh yeah, but he said that he wanted to do that because sometimes we'd put it where the something is, and he didn't want it. But yeah, that is your K.
So you get now?
Yeah.
And now that you move this exponent over 1, there's a 10 here, the -1 power. And when they're next to each other, you add them. And since it's negative, it's basically subtracting, which gives you a power of times 10 to the 4th times. That's it. Here.
good. You have any questions?
No.
Okay.
Thank you.
So logistically, my students are trained into routines that make our group work flow a lot better. Since we work in teams throughout the year, one of the things that I do to make the group stronger is in each group, they always have the same 3 roles. So in our group, in our class, the 3 roles are a results coach, a prep coach, and a process coach. A results coach is responsible for reminding their team of deadlines. Where is it going to go? The prep coach is responsible for getting there early and getting their team off to a strong start. Every single day we have a warm-up. It could be content, but a lot of them are logistical. And by logistical, they're questions that I want the teams to have conversations about to really enhance their teamwork. So it could be, when is presentation day, according to the agenda? What are the odds that your product will be done by presentation day? And they rate themselves. What do you plan to do differently today? If you feel off track, what do you plan to do differently today, and what are your goals for the day? So those are, if I'm not doing a content warm-up, a lot of their warm-ups are structured like that.
You know the second one when it says that the force equals 40, and then the distance had been divided by about 1/2. It's 0.25 times 40, right? And it's 10.
0.5 squared. Wait, because the answer, I'll give you the answer. You have to try to find out.
The day before we had a full launch of this project was the day after they had taken a big state assessment. So they were wiped out, they were exhausted. But we still wanted to take them further into the project. We didn't want to stop and just have a free day, so we decided to do a soft launch. So during that soft launch, it was just more about starting the conversation that would lead them into the topics that were going to be explored in the project. So on that day, since we were going to be doing conic sections, Banks had them cut Hershey's Kisses along different cross sections and look at the shapes. So he can begin to talk about cross sections of conic sections and how those produce the different conic sections. Also on that, we had them draw a planet that could be habitable and what its characteristics would be. And we just got crazy things, because they were just wiped out. And we just let it flow. At that stage, it was more about starting the conversation. After you process that, we're going to actually look at what the research says. So you'll read this. It's a really brief article that lists some pretty key things.
We need a source of energy so the plants can survive. So I guess we need energy, water, land, plants. Because that's how we get oxygen. That's 4 things. Also put so plants can grow and no one dies of dehydration.
So in this project, they were dealing with planetary motion, and also, as far as Algebra 2 is concerned, conic sections. So we wanted to look at those items and decide what information is important for them to know at the very beginning of the project and what information do they need to know. So as far as Algebra 2, they've seen circles since they were in 2nd grade at least. They've known about planets being in some kind of motion since about that same time. So they have a background on planetary motion and conic sections. For the entry doc, I just wanted to introduce some words that they were going to need to learn about. And it kind of builds a little curiosity, or at least you hope it builds some curiosity as to what those things are and how you're going to use them. Our rubrics are done in Google spreadsheets, and we have some coding involved, which is pretty simple, and it's not that hard for teachers to learn. And it'll change colors based on if something's completed or not. And so that way the students can see feedback on what's finished and what needs to be finished. We give them deadlines and we tell them which section of a rubric is due by what time period, and we'll remind them in warm-ups and things like that to kind of keep them focused. A lot of times what we'll do to help manage it so they don't freak out right away and think that there's too much to do is we'll hide later sections of the rubric, so they'll only have one section of the rubric to focus on.
So yes, the rubric is aligned. Does that mean it's the law? Yes and no. There's some teams that are ready to go even farther than what we say. So sometimes they'll express things that I think are valid and that kind of align to our standards or just valid to pursue, and I know they have the time. And then go ahead and show me how you're gonna show me how you calculate lifespan of these guys, and that'll be it.
Wait, so if we show the example of us calculating our lifespan here, then does that, or
Lifespan and your inner and outer radius of your habitable zone, that's 1.5 in the rubric.
Wait, does that also take off for the 1.1 or for having an example? Because we showed the example here by using it to calculate this. Would that count as
This
an
lifetime, yeah, I'll accept it. So we can negotiate how a part of the rubric will be assessed if they're going to take that new direction. And I'll structure that choice.
Oh, on this one, here's what I've told people that got stuck on this. When you're selecting your planet masses and planet radii, it's okay to use our solar system as a template. We know that Pluto is a debatable planet. Sometimes they put it, sometimes they call it part of this belt of comets. Sometimes they call it a planet. I don't know. Every time I check the news, it's different. But we know at least that part of why they're arguing is because it's so small and so far away. Okay? So you might want to set that as a lower limit for your mass and your radius. And then we know what the biggest planets in our solar system are. The sun. So you might not want to make your... I'm going to pretend I didn't hear that. No, don't go away.
As we were going through, they were getting stuck a lot on some of the physics parts and not getting all the way through the algebra parts. So we saw this coming, and Dr. Trinidad and I talked at the end of the second week, and we decided what we would do is we would take that third part of the rubric and just make it more advanced. So in order to get from, say, a 90 to 100, you need to be able to finish the third rubric piece. But if you don't finish it, you can still get a good grade. You can still get up to a 90 if you finish everything else.
One thing that's different also is I made it less calculations in this table. Initially, I was having you calculate the gravity here and here. Now we're just going to calculate it here for all your planets. Okay. That's the closest space. Okay? And if you don't know how to define this distance, come talk to me. If you're going for proficient, you're just going to do the distance between those. If you're going for advanced, you're going to include the radii of your planet and your star in that calculation.
So scaffolding for me includes like all of the little workshops you do and the assessments that you use to make sure that the students are on target and learning the content that you intended. Like we don't get our oxygen from the moon. What does the moon do for us?
I told you we need the moon.
Huh? That's part of it. What else does it do?
It does the tides, right?
Mm-hmm.
Holds the ocean.
Creates the tides. What else does it do? You know how the moon has lots of craters? What caused those craters?
Us landing on it?
Oh,
no.
Oh, it blocks asteroids.
Okay.
It's safe.
And if you're really good, you want to be able to make that scaffolding interesting because it links to the need-to-knows of that project.
Everybody send one representative to the front. I need to explain something that is going to impact everybody. There's a unit issue that we've uncovered just from the references we've given you. There's two lengths that you're giving us that are important for your graph of your solar system. One of them is the radius of your star, okay? And the other one which kind of defines the size of your star, right? The other one are the radii for the inner and outer boundaries of your habitable zone. Unfortunately, the information are in two different units, and we can't have them in two different units if we're going to create a scale diagram. So we have to figure out how to resolve that. So we're going to go over that right now.
Because oftentimes what happens when you're writing the projects is you're writing the project as you're going. And this happens even for the mature projects because you'll notice a misconception and you're like, no, we need to address this misconception. We need to tweak the rubric or tweak the scaffolding so we can take care of this right now.
The conversion factor for that is in the briefcase. There's a document called hints something something something. Open that up so you can look up the conversion factor. So once you figure out this number, you can
So
convert
these
it.
are in solar radii.
Yes.
And then whatever number we get, say it's like 100, we convert that into meters.
Yes.
Okay.
The gravitational force between the sun.
That, you have your notes like the homework you did for Mercury, exactly like that.
Okay.
Also in the briefcase, there's a gravity force checker. So after you've finished your gravity forces, plug it in there and tell me to refresh it and we'll tell you if you got it right or wrong.
Okay.
I'm gonna leave this with you.
Yay.